Today we will be presenting on the Deepwater Horizon oil spill, one of the largest marine oil spills in history. On April 20th, 2010, the Deepwater Horizon drilling unit exploded, catching fire and eventually sank after a blowout occurred during drilling operations. This disaster led to the death of 11 workers and the release of 134 million gallons of oil into the Gulf of Mexico. The spill was caused by a failure to properly manage operational risk and safety protocols during drilling, and it had devastating impacts on the environment, the economy, and the lives of many along the Gulf of Mexico.
Now we will analyse some of these root causes using a fishbone diagram. There are 5 main categories contributing to this operational failure: equipment failures, processes and procedures, human error, management and leadership, and environmental and external factors. First, equipment failures played a major role. The blowout preventer that was supposed to seal the well in an emergency failed to do so. It was later discovered that the preventer had serious design flaws and mechanical failures, and records show that these issues were known but not addressed. Additionally, the backup system, the shear rams that were supposed to cut through the drill pipe, could not cut through the pipe as it was bent. This failure shows how equipment in high-risk operations must be robust, maintained, and tested. Second, the operational processes and procedures were deeply flawed. Critical steps like testing the cement seal around the wall were rushed or skipped. Halliburton's cement design was unstable, and BP skipped a safer cement bond log test to save time and money. In addition, pressure tests before the blowout showed abnormal readings, however they were either misinterpreted or dismissed. Third, human error played a significant role. The rig crew misread a negative pressure test, a clear sign that oil and gas were leaking. They mistakenly interpreted it as okay. There was immense pressure from BP's leadership to speed up the process because the project was already over budget and 6 weeks behind schedule, costing BP around $1 million a day. This pressure created an environment where decisions were made too quickly. Additionally, warnings such as unusual pressure readings and unexpected mud loss were downplayed or ignored instead of triggering an inspection. Fourth, at a slightly higher level, BP's corporate culture emphasizes a cost-cutting and efficiency over operational safety. There were also poor communications and finger-pointing between BP, Transocean, and Halliburton, with no single company taking full responsibility for well safety. Finally, environmental and external factors played a role. Deepwater drilling itself poses extreme technical challenges due to the environmental conditions. The depth where Deepwater Horizon operated at about 5,000 feet underwater made real-time responses very difficult. Additionally, regulatory oversight by the U.S. Mineral Management Service was weak, underfunded, and often compromised by conflicts of interest with the oil industry. This lack of stringent enforcement allowed unsafe practices to continue largely unchecked.
So next we have recommendations for risk mitigation. If BP had implemented stronger and more consistent risk management practices, this disaster could very likely have been prevented. First, there should have been mandatory independent verification of all critical operations such as cementing, the well, and pressure testing. An independent third-party inspection would have ensured that shortcuts were not taken under internal cost or schedule pressures. Secondly, regular maintenance checks on all emergency equipment, especially the blowout preventers, should have been a requirement. It is not enough to assume that equipment will work in an emergency. It must be stress tested frequently under realistic deep water conditions. Third, BP needed to foster a strong organization-wide safety culture starting from the very top leadership levels. BP should also focus on fostering a strong top-down culture of safety rather than the one of cost-cutting. Finally, real-time monitoring technologies should have been installed and fully utilized. Advanced sensor systems could have provided earlier warnings of dangerous anomalies, such as abnormal pressure buildups, giving the team more time to respond before a blowout occurred. Finally, in conclusion, the BP Deepwater Horizon spill is a clear example of how failures in operations management across equipment, processes, people, leadership, and external factors can lead to extreme consequences. By putting risk management and safety at the heart of operations, companies can prevent disasters that threaten lives, the environment, and the company's own future. Thank you for watching.